The sky is falling. The sky is falling. That's what the newspaper said all over the world with remarkable consistency. Everyone was freaking out in the first week of October 1957. If you know your history books and you're a techie, you might know that's the date that the Russians launched Sputnik. Catching everyone in the U.S. By surprise. Normal Joes on the street were fearful that the Russians were going to invade next. It was, cats living with dogs stuff. It was horrible. The team that was most intimately concerned with this, more so than the average Joe, was the team of engineers and scientists who worked on the Vanguard project. Vanguard was the U.S. Army's attempt to do the same thing as what Sputnik was trying to do. I will say parenthetically, because of Sputnik happening, that pushed the U.S. to create NASA. Like a month later, President Eisenhower signed the whatever to bring it into existence. But this was before that. The team from the Vanguard project were under a great deal of pressure, as you can imagine. They had been trying for several months to get to this milestone and hadn't been successful yet. They just weren't ready. A month later, the Russians did it again in December, as if to say, we can do this anytime we want. Then there was really a bunch of pressure on the team to prepare. So they were put under the gun to launch something on December 6th. The team gathered, they did all their tests, they were under a great deal of pressure, a lot of it was riding on it, prestige, money. Does this sound familiar to any of your projects? I don't know if you know your history, what happened on that launch, but I have a little, oh wait. I need a mic for I forgot to do that. This is important, you need to hear this. Yeah, cool. Okay, here we go. Let's try that again.
Pounds was checked out by scientists and declared ready.
Can you hear that?
A great wave of advanced publicity focused attention at Cape Canaveral, Florida, for the launching of Test Vehicle 3 of Project Vanguard. A preliminary to the scheduled launching of a 21-pound satellite in March. What happened is already unhappy history. Another setback for the United States in the race into outer space. Here are official Defense Department films of the launching of the 72-foot missile, a loss of thrust, and fall back to Earth in split seconds.
I love the music in this part. It's awesome.
The exact cause is classified. Neither the satellite program nor our missile development is affected, said Acting Defense Secretary Quarles. It's only an incident in the perfection of the Vanguard satellite system.
Okay, not to contradict what the man here said, but actually they did know what caused this. And I know this because when I worked at NASA, my boss was one of the people that worked on the analysis of what happened in this launch. And you might be surprised what caused it, or maybe you won't. See, it turns out that every time they did a launch on Vanguard, they had a team come in, and they would clean up the launch pad. They would fix things like wires that got messed up or pipes that got destroyed or whatever, because it's kind of a violent thing, the whole launch thing. One of the things that tended to get damaged was an umbilical that plugged into the base of the rocket. An umbilical, in this instance, is just a glorified name for an extension cord. But it plugged into the base of the rocket, and it seemed like every time they launched, the connector on the end would get messed up. So the electrician teams would come in, and one of the things they would do is they'd be like, oh, messed up connector. I know what to do with that. They just cut it off and put a new connector on like they're supposed to do, doing their job. The problem is, every time they did that, they cut the cord, and it got shorter and shorter and shorter until the day of this launch, when they were prepping for this launch. What's funny is the electrician was doing his job, but he was introducing a variable into the system that no one had accounted for. And I think the point is we do the same thing when we do some of our systems. Everybody's doing the right thing. Everybody's doing their job. Everybody knows their job. Who could fault the electrician for doing his job? But it created a catastrophic situation for the launch. And the reason why it was catastrophic is because the way the launch control system was set up, there were at least two primary systems on that rocket. There was a ground-based system and the primary flight control system. The ground-based system handled things like starting the pumps up, lighting the motors, that sort of thing. So it started up and started the process off. When the umbilical was pulled out, that was the clue to switch the computer systems from one to the primary flight control system. So when it pulled out early, the first one shut down, just like it was supposed to do, but the primary flight control system went, hey, it's too early, I'm not going to start up yet. So the whole stack collapsed, and we see what happened. Interestingly, the satellite itself got ejected from that and was fine, and is in the Smithsonian right now. So anyway. And I gave you that long intro. It's like my title is Building Virtual Development Environments with Vagrant, but I'm really subtitling it Stop Cutting Cords. Because there's things like that we're doing too, and it impacts our deploys, just like it did on the day on that rocket on December 6th. My name is Mike Hagedorn from Houston. That's my Twitter handle. I work at silverchairsolutions.com, which is me. And we're going to talk about virtualizing your development environments with Vagrant. Go through a bit of an agenda first. We're going to talk about some reasons why Vagrant is a good idea. I think I've just given you a really good reason why, but we're going to try to tease out some other ones. We're kind of going to do the very simplest hello world that we can do. Then we're going to talk about how you can get a little more complicated using provisioning with Vagrant, which is where it starts to get interesting. Our examples are going to get more complicated, and then we're going to do something that's like a real Rails app, so we can see how one would actually use this for the jobs that you are doing out there. And then we're going to look at some other cool stuff. Okay. First of all, how many times has someone come to you and said, "Hey, look at my cool website here. It's just on GitHub. Clone it, and then do a Rails S, and it boots up." That happens to me like, okay, maybe 5% of the time. Maybe on Planet Perfect that works, but I don't live on Planet Perfect. I live here on my planet where you do the git clone, and then you have to do some magic incantation. And you have to sacrifice a goat, and the moon's got to be in the right position, and you install a bunch of stuff, and then you do the Rails S, and then it comes up. There's a big they go, how do you do that part? It's not documented very well, typically. It reminds me a lot of, and if someone actually finds this link and sends it to me, it'd be great, because I could not find it, and I know I've seen it. I read it in college. There's this Far Side where there's two scientists standing before a board, and one of them's writing a math problem. And he writes all this stuff down, really complicated proof. And then he leaves a gap in the middle, and he writes the answer on the far right, and then Millie writes, and then a miracle happens. And the other guy from the far side says, I think you should be more specific on step 2. And that's very much how booting up some of our systems ends up becoming. There's all this magic in the middle that just creates problems for us. So this is kind of a idealized view of our servers. You have your OS. And you have your app server and your database and web or whatever else makes up your stack, right? It's just sitting here all nice and neat, sitting on top. Except, again, that's Planet Perfect. That's really not how things are. Really, it's more like this. You have all your app stuff. We'll go over here now. But you have all this user space stuff mixed in with it. Things like maybe versions of programs that contradict what needs to be in your app, perhaps. Or just stuff that consumes memory or whatever and impacts what you're trying to do. It's not a nice, neat thing. Typically on our laptops, we have a bunch of crap as well as the programs we're trying to run. And that creates problems for us. There's no isolation between our apps and the stuff we normally run. It's not repeatable because we probably don't remember the trajectory it took to get that stuff installed on our laptop, and sometimes that matters. And it's not reliable. Like you could give someone some instruction that you work with, say, oh yeah, just install this and this and this. And sometimes it works, sometimes it doesn't. And works on my machine is not a valid response most of the time. And I've used that too, we all do. A really good solution for this is virtualization. And I've kind of hinted at that earlier. In this case, if you virtualize, you still have all your user stuff and it's still there. But it's nicely sandboxed away. It's all the stuff that you're really trying to do, all the money stuff, is packed away inside this virtual OS and isolated from that. Your application code can be siloed. It's repeatable, it's controlled, and it's reliable. And that's assuming, of course, that you've bothered to do things like check your chef scripts or whatever into source control. And if you're going to do this, you would probably do that anyway. So it's a big win. Additionally, you don't have to spend all day configuring it. Like when you bring a new person on a team, often you'll spend a great deal of time configuring the system and setting things up, particularly if it's complicated, like message queues and stuff like that. Your server configuration is source controlled, probably, if you're going to do this. But another really interesting win from taking this approach to development is it allows you to do what-if scenarios with your stack. Like you want to test out a different message queue or whatever, a different database even. Having a tool like this will allow you to switch that out and test it real easy in development. It's cheap and easy to try this stuff, and you're not going to impact your test servers or anything else or impact the rest of your users. Vagrant is a layer that allows you to do a lot of this stuff. It was written by Mitch Hashimoto, and I hope I'm saying that right, and John Bender. The first GitHub commit I found was in January of 2010. So it's been around for a while. It's in version like 0.82. Somebody needs to make a joke about nobody ever wants to go to 1.0, but anyway. It heavily leverages VirtualBox. I think most people know what that is, but some may not. It's a virtualization solution that was originally written by Sun, and of course, when Oracle bought them, they inherited it. It's free. Works pretty well. Vagrant allows you to do provisioning via Chef or Puppet. I'm not going to get into the religious discussion about whether one should use Chef or Puppet. I've been using Chef. Most of the examples you see with Vagrant are using Chef, so that's kind of the route I'm going to go. There are other provisioners one can use via an extension API, or there's even like a bash script provisioner if you don't want to use any of those. Vagrant also does a really good job of mapping shared folders from your working directory. Maps one into the space of the running VM, which we'll see that in a second. It allows you to do some really cool stuff. And makes real easy to use SSH access so you can get to your box and do things. Installation, pretty standard. What you do with any other Ruby thing, it's a gem. So you gem install Vagrant, real easy. That's boring. This is a little more interesting. How did I describe it? Vagrant boxes are basically like AMIs from the Amazon world. They're just images of boxes that you're going to clone and work from. So this command, what it does here, this Vagrant box command, it allows you to download an image from somewhere else, or it could be local if you've already downloaded it, but in this case I'm pulling it off the web, and store it on your local, in your home directory, actually a directory called boxes, and then your other projects that are Vagrant projects can make use of that. And it's like they each get a fresh copy of that base box. So you can mutate that, but it doesn't change the base box. You get a fresh start every time you clone, so that's kind of cool. In this case, that distribution there happens to be Ubuntu. That's kind of the base one they go to, but there are other boxes, as I said on the slide, available at vagrantboxes.es. You know what? That's wrong. It's vagrantbox.es. Vagrant boxes. That's wrong. But anyway, you can see other ones there. And we'll talk about later, you can package up your own as well if you don't like any of the distributions that you see there. The next thing you do after you download the box is you create, I didn't show this, but you create a directory, a project directory where you're going to do all your work with Vagrant. And you do a Vagrant init. And that's sort of like a Rails generator, kind of. It generates a Vagrant file. The Vagrant file, we're going to see an example of it in a second, but it's basically like all the metadata that one would need to boot this thing up and configure it and map things like ports and things like that. Vagrant init will generate that for you. And finally, after you initialize the file and edit it to your liking, you do Vagrant up. And what that does is it reaches out and grabs the box that you list in the Vagrant init command. It boots it up. It pulls it into the memory space of VirtualBox. and then starts to run it. And optionally, it provisions it. Like perhaps you've enabled provisioning for that box, and it will do that. This is what a Vagrant file looks like. This is absolutely the drop-dead simplest Vagrant file you could have. It's just telling it which base box to use. In our case, it's one called base, which is when you when you download a box and don't give it a name, it defaults to base. Or I'm sorry, the last one we did is base, but if you don't give it a name when you generate this file, it defaults to base. It's assuming base. You can also, I didn't do this for this demo, but when you do a Vagrant init, you can pass it a name so that this would get populated correctly. And we're going to do a demo now. Let's see. Let me show you that simple that is. Can you guys, hey, where's my, is it over? There it is. Oh, great, I get to type. This ought to be really fun. Help. Thank you to our technical support. Oh, turn on mirror, and then I'll just turn it off.
Yeah.
Okay, right on. Thanks. Yeah, the alternative would have been brutal. Okay, just to admit, I've cooked the books a little bit here because it can be painful watching these things boot up. It usually doesn't take more, in a very easy case like this first demo, it's usually no more than 30 seconds, but I don't really want to be standing here juggling while it's going on. So I've already provisioned these and booted them up, and they're suspended, and I'm just going to bring them out of suspension, so to speak, because that's faster. If you don't ever know what to do with Vagrant, you just type Vagrant, and it gives you some lovely help. Can you guys see that? Is that working for you? Okay, cool, thanks. So we're going to do, let's just see what's going on with this box. We can do Vagrant status. It's probably going to say saved, yeah. So we're just going to bring it up. Now because it was saved, it was suspended actually. You can see it said resuming suspended VM. It should come up a lot faster. This is just in a base Ubuntu box, pretty boring. We're not provisioning it, so nothing terribly interesting is going to happen. Now it's up. So let's go in there and look at that by doing the Vagrant SSH command, which is going to bring us into the box. There we are. Now here's what I want to show you about this demo that's kind of interesting. By default, your working directory where your Vagrant file is mapped to the /Vagrant directory in the running machine. So let's go there for a second. And it should look remarkably similar to what we had before, which it does. But check this out. Let's get out of there. Let's exit out of the machine. Let's create a test file, just some dumb file. And I don't know, put some stuff in it. This is my hello world, literally. And let's go back into the machine. Now check this out. Now that text got mapped into the world of the running virtual machine. And just to prove I'm not faking that, let's go print that out. Oh. Did I spell? Oh, txt. Oops. There it is. So that's kind of cool. So that's going to have some implications down the road. That means we can do arbitrarily interesting things in our working directory, and they get mapped onto the machine. And we don't even have to we don't need to use Capistrano to push it out there or anything. It's just there. That's kind of cool and powerful. Okay. Let me shut this guy down because I don't want to burn the memory. We're going to suspend him. Thinking. Okay. So now, where was that? Turn off mirroring, right? Right on. Oh, now I need to switch displays. Where is that at? I'm a wreck without tech support. It's a magic incantation. We're cutting cords up here.
We need a gem for this.
Yeah, we need a gem for this. Right on.
Wait, what did you want to happen?
Well, I wanted to switch it back to the other. Let's see. That's right.
Okay.
Yeah, cool. Okay. Forward and onward. We talked about some of these just now, but here are some other commands that you can do with Vagrant. There's a whole bunch of commands to manage boxes. So you can like do Vagrant box list to see all the ones you've downloaded in that hidden directory in your home directory called .boxes. You can remove boxes. Interestingly, you can't rename them, which I'm not sure why. I should send an email to the guys to figure out why that is. We've done Vagrant up. Halt is the opposite, shuts it down. Vagrant destroy is like halt, but it also destroys completely the image that got pulled into VirtualBox. So if you want to clean up and save resources, you can do that. Vagrant suspend and resume are just merely freeze drying it or bringing it back out. Those are real handy too. We're gonna look at. What am I doing that time? Okay. We're gonna look at provisioning next. It's kind of funny. Vagrant, when it starts working, as you can see, it kind of steps into the background. You don't really see it anymore. It's kind of like Charles Nutter was talking about at RailsConf a few years ago, after he got JRuby written. It really wasn't about JRuby anymore because it was just Rails or whatever. It's kind of like that with Vagrant. The stuff just works. It brings up the virtual machines and it does. It maps things for you, so you can just use it. So we're actually going to talk a fair bit in the last half of the talk about provisioning, because that's where you seem to spend most of your time when you're doing this stuff. And for some reason, we're going to be basically talking about Chef, but for some reason it seems to be, and it was to me too when I started, a little bit obtuse, and I'm not sure why that is with Chef, but it's kind of hard to get started. This is a kind of a diagram of how the provisioners work in Vagrant. You have your base Vagrant stuff, and it's got a layer of abstraction here for the provisioners, and then some provisioners plug into that. And they're the ones that actually do things to the target OS, mutating files, dropping files on there, whatever. And this is one of those things, the customizing provisioners, that took me a while to get and figure out. I'll be honest that in my examples I'm not doing a lot of this because I kind of cheated and wrote my own recipes that do what I want. But in general, one wouldn't do that. You would download a recipe for like installing MySQL, and then you would add properties to that line of highlighted to customize them. And that's kind of strange because like when you read all the Chef documentation, they really kind of have a slightly different context how they're using them. So that's really not how this kind of stuff is handled. So when you're in the Vagrant world, it's just slightly different. And it's a little bit like if you speak Italian, you kind of get Spanish, but you don't. So you have to stumble a bit. So all this stuff I'm doing is checked into my GitHub repo. And I'll post it at the end so you can actually have these examples and maybe save you some time because it really kind of tweaked me at first when I was doing it. So anyway, but that's how you would customize a Chef recipe. As I said, they're Chef Solo, Puppet, and a custom provisioner. And there's one more, which I forget the name of, it's just released, is supported by Vagrant. We're mainly going to focus on Chef Solo, which is sort of kind of Capistrano-esque, I guess. Chef is more server-based. It's just easier to use. And since we're talking about Chef, a bit more about that. It abstracts away all the configuration details for a platform. For instance, several Linux distributions have different ways to do packaging. There's apt-get and there's other ones. But in Chef, it's just package, and it figures out the right thing to do when it gets dropped onto the platform. It provides a real cool DSL to manage your servers. And here's a 50-cent word for you, idempotent. And I had to look it up what it meant. It means if you do it twice, the result is the same. And this is important for when you do an operation to a server. If you do it again for some reason, if it's already been done, you just need to blow it off and not do it again. And Chef respects that. If you're writing your own recipes, you have to do a little work to make sure, if you're doing it the Chef way, that you respect this as well. It's written in Ruby. It codifies best practices of the community. We've already mentioned this a little bit, but the installation components, the individual ones, are called recipes, and a collection of those are called a cookbook. They can be either server-based, which is Chef, or standalone, which is Chef Solo. The major difference is if you're using Chef Solo, it's basically the same code, but the cookbook's stored locally and typically with the source code itself. And some people they don't like that. They like the purity of Chef, where actually the cookbook stuff is stored out somewhere else on the web. I think it's convenient, so I don't really care. So recipes for Chef are like Ruby gems for Ruby, basically. That's a good way to think of it. Little components that do something to provision your server. This is an example of, if you can read that, this is kind of how the cookbooks lay out in your project. So in this Vagrant Pitch 2 project, there's a cookbooks directory that has, in this case, Apache, APT, and Vagrant main inside the cookbook. And then there's some other stuff that we're going to see later, and there's a Vagrant file. We're going to come back to this because we're going to walk through this example, but I just kind of wanted to show you typically where you'd find the cookbook and how it kind of is laid out. This is a Vagrant file for kind of this next example we're going to do. This is more interesting than the last one. There's more going on. We're going to actually forward the port from the web server to port 4567 out and the host when we hit it. We've also enabled provisioning here, and we're going to use Chef Solo. And we're telling it where the cookbooks are, which is, we just saw that in the last slide. And this is kind of a Vagrant convention. This is basically saying when you get ready to provision, run this recipe. And if we look back at the last slide, probably, I don't know if you can make this out, but that Vagrant main is going to run actually this Ruby file. And it's kind of a convenient convention, I guess, in the Vagrant world, where you have a Vagrant main, which is sort of like a main in a C program, and then you put all the details of what gets called inside of that. I don't know, they do it a lot in the Vagrant world. Yeah, we talked about the cookbooks. We talked about the recipe, yeah. So let's look at that. Okay, turn on mirroring. Okay, get out of my way. Demo 2. Cool. Okay, I don't remember. I think this one is suspended as well. Let's see. Yeah. So let's boot this guy. I'm going to show you what it does first, and then we'll look at some of the components and how the provisioning worked in this case. It's basically just putting Apache on a box and writing some directories and some config files and stuff. It's pretty simple. Let's go to 4567. So there's, pretty boring. It's a web site. Yay, we've seen that before. But let's, just to prove that I'm not cheating here. Oh, I don't have to do that. Index.html. How about that? And we do this again. La 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 la. There it is. So you saw me live editing. So of course the implication is that was a simple, stupid example, right? That was a nothing example. But it could be something a lot more complicated. It could be like a really complicated Rails app or whatever you want, and it picked up those changes and flipped them into that world like instantly. So that's kind of the big deal, really. Okay, let's look at how that was actually done in more detail, because that's really where the devil is in the details on these things. It's demo 3. I can just mate from here. Wow, this looks weird in this resolution. Okay. Basically, we're just launching, we look in the Vagrant file, but we're launching Vagrant main. So let's look at that to see, we kind of saw it on the other slide, but let's just have a peek at that, basically. Recipes, default. So we're requiring 2 recipes. In Chef, everything runs in order. So it's going to do the APT thing first, which is updating some packaging stuff. Then it's going to drop Apache 2 on the box. And this is going to take out the default site so it doesn't appear. And this little ditty here will actually create the configuration file to point to the doc root being our Vagrant directory. And what's sort of interesting about this one is Chef has these notion of templates. And so it's going to use that template I've highlighted there to do its thing. So let's have a look at that. You can see basically it's going to create a virtual host and write the document root to basically our Vagrant directory. I'm not going to go into too much detail about how these variables get set up, but you can figure it out from reading the English, sort of what it does. And that's really kind of the point. It's supposed to be an English readable DSL. So is there anything else interesting in this one? Not really. I'm not really doing anything to the default installs for Apache 2. So this brings in the element of it reflects what the community thinks is a good way to install stuff. So you don't have to think about it. You just require the recipe and magic happens. So okay, that's okay. That's HTML, but you and I don't usually live in that world. We usually live in something a bit more complicated than that. We usually live in the world where we have like a Rails app and a bunch of other stuff, and so that's where the money play is, right? That's where the more interesting stuff is. Wow, 32 minutes already. I'll try to move quick. I'm not going to actually do a Vagrant up on this because I found that when I was doing this, sometimes the provisioning takes longer for this, and for some reason, this particular recipe, there's a lot going on. Provisioning was taking too long, and it just really doesn't demo well. And there were some other technical issues with the network here in the thing. But I can show you the interesting bits that were when I was attacking the problem, how to provision this, and that's really where the more interesting stuff is anyway. You've seen Vagrant run, so that's really not where the money shot is anyway. So let's have a look at this directory. So what this example does is it takes actually a pretty complicated Rails app, fat-free CRM. I don't know if you've ever looked at it, but it's a big honkin' Rails app, and there's a lot going on in it. Fat-free CRM has some default tasks to set up the database, to set up some sample data, and all that. So I needed to find a way to automate all that as if I was provisioning that whole thing. So as you would expect, oh, this is important too. This is actually what the Vagrant config file looks like if you generate it. I stripped out all the comments and stuff before, but much like Rails will put in stuff for you to kind of help you and give you examples, Vagrant does that too. For the purposes of giving an easy example though, I just deleted all that stuff that wasn't relevant, but this is actually what gets generated when you do a Vagrant init. And it's very informative, but it's also like a lot of noise, so I deleted it all out. But I just wanted to show you that because that's kind of interesting. This one, what else is interesting in here? Let's just look at the Vagrant main to see what's going on here. You can see you have a lot more recipes in this one. The first thing it's going to do is install MySQL using the package method for both the server and the client. And then this is the first one that I wrote, copy database stuff. Now let me tell you what's going on with that one. When fat-free CRM ships to you and you download it or clone it from Git or whatever, it sort of gives you, as you can see sort of here, it gives you some default database YAMLs for all the platforms one might deploy to. We're using MySQL, so the idea is for that recipe, it needs to copy this file basically over the top of this file. So that's what the copy database YAML recipe does. And it's just using some declarations like cookbook file. This is the ultimate destination for that file. And it's sourcing, I'm cheating a little bit because it's sourcing it from here, which is a file I buried within the recipe. So that's cheating a little bit. I should have actually probably pointed it to one of those files inside the Rails app, but this was easier. And it's my demo, so. I want to point out something. Is it in this one or the next one? Okay, it does that. Then it does, we install bundler. And then we install git. And then we do, basically we're going to do a bundle install. The reason why is we're going to get ready to run some pre-built rake tasks that are in with fat-free CRM. So I have to have everything set up in the Rails app just like I would have had it done by hand. So what's interesting about the bundler install, though, is I cheated again, and I went into the default attributes for that recipe, and I set the place in the file system where I stored that stuff so that it knows where to, basically in this case, if you look at the other recipe, it's going to go to that directory in order to, you can see it's referencing it there, but where to install and where to do the bundle stuff. But anyway, that's kind of an interesting point. Here is one that I really should have spent a little more time on, but it illustrates a really important point. This is where the rake tasks are going to start running. If you go to the Fat-Free CRM site on GitHub, and you'll see that they tell you to run these rake tasks. It's pretty easy. It's just bash, and I go to the right directory, and I do bundle exec, rake db, whatever. This creates the database. This one sets up some lookup tables and stuff. And then this one does load some demo information. But what I didn't do here, and if I were to show you the provisioning, it would take us all the rest of the day, but I'm not going to. I'm just going to tell you what it does. I didn't really honor the idempotence thing here. If I was really going to do this right, I would have put inside here something like not if, and then like check for the existence of that database. And then Chef would go, oh, I don't have to run that because it's here. Or you can do only if here. So that's just kind of someone wants to hack this, and from my GitHub repo, they can feel free to do that. That would be the right thing in that case. But it's pretty easy to write recipes. I just wrote some custom ones because it's easiest to understand stuff when you start with something easy. Some of the chef scripts, the chef recipes you find online are really complicated, and there's very meta, so it's kind of intimidating sometimes. What else? That's pretty much it for that. Let's go back to slides, I guess. Okay. Help. What's that trick again? How did we do that? Yeah, but forget it. I'll just forge ahead. Without my notes. Frightening. Other commands, like if you're in the middle of developing one of these things, a provisioner, and you don't want to have to do Vagrant up or bring it down. It's a drag. It's really slow. So you can just do the provisioning part if that's enabled. That's a very handy command. You can also do multi-VM setups. Like if you're really trying to closely model what you have going on in a system you're doing, you can do something like this where you have multiple IP addresses set up and port mappings and stuff. That allows a really high fidelity model. It also probably requires like 6 jillion megabytes of memory, but so I'm not going to do this on my laptop. Nothing I'm not going to demo, but theoretically one could get it to work. I guess a lot would depend on how much you've customized your base boxes, how much memory they consume, how lucky you would be with this approach. But you can do it, and that's cool. Okay, so we've seen how we can provision servers, seen some easy demos, and that's really cool. But if you're going to share this with like someone else in your staff, like a graphic designer or somebody to run the actual app, they're not going to want to see all that provisioning stuff. They're not going to want to care, frankly. That would really stink for them. It's more knowledge than they want, too much information. So what you can do, it's analogous to snapshotting. When a box is up and provisioned and running, you can take a snapshot of that and create your own box. And you do that by doing Vagrant package while it's running. And this little part of the command is really important because if you're doing anything non-trivial, you're going to want to have mapped ports. And if you don't include the Vagrant file, you're going to get, for security reasons, the default port mappings, which means you won't be able to get to anything on the box. So that include Vagrant file is kind of important. So when you do that, you end up with a Vagrant or package.box in your same directory. And then the other person, when you give it to them on a disk or put it on your network or whatever you do, they have to do Vagrant box add. In this case, this person's naming it test. And that's how they would make use of that. And then they would do Vagrant up or whatever. That's kind of all I have. That's my contact info. The slides for the demo are here. Please rate me. There's a bunch of resources. The first one is the Vagrant site. The second one is where you can find some other boxes. That's the correct address this time. And the last two are some really good chef resources. And I know someone's going to ask me why I didn't do Puppet, but I just haven't, so I don't use it. But anyway, that's all I have. If anyone has any questions that I can answer, I would welcome them. Anybody? Hey, Scott, what's up?
Hey. First of all, great job. This was an awesome talk. I have a question and a comment. The comment, just quickly, the whole reason for, or one of the things that's important about item potency for those recipes is that when you do a server client version of Chef, the client, which would be one of the production machines, will be pulling those recipes from the server every next period, 10 minutes or 30 minutes. So you really don't want to stomp over, running.
Yeah, I'll concede I've only really used Chef Solo, but
no, I mean, even if you do that, you should be able to run Chef Solo over and over and over again until you get what you want. The question though, and I think you kind of covered it at the end a little bit, but I wanted to see what's like a best practice for including your Vagrant file and this whole setup so that you could share with other users. Is it that sort of like enclosing folder and then cookbooks and Vagrant file and then my Rails app?
Well, in order to boot, it's kind of interesting because you're going to have to include Vagrant file, and it's going to get embedded inside the package, and then the ports are going to get mapped, like I said. But really, for your user to run it, if you don't have a Vagrant file, it's not going to know how to boot it. So your graphics designer is going to need they're going to have to create a project directory, and then they're going to have to do Vagrant init and set the name of the right box anyway. So they're still going to kind of need one, but it would be very simple, and it might just because the Vagrant file really gives you an opportunity just to customize what the box is. So what the win is you would have a very small Vagrant file for that person, for that designer or that contractor or whatever. Most of the goodies would be sort of hidden inside the box.
What actually comes out of the box when it's packaged? Like what?
I've not looked at detail. It's just well, it depends on, there's some rules of thumb, like you don't want to create a package that's bigger than, like they say 500 meg is, don't go bigger than that or no one will use it. I've not really cracked inside it to see, but anyway, I guess I've not really looked for the Vagrant file buried inside it either. It must be hidden in a temp directory somewhere. That'd be interesting. I should do that. Cool. Go ahead, Ray.
Just curious, so how usable do these things end up being out of the box? Like I assume a lot of people struggle with Passenger trying to get those things.
Well, out of the box, like the Lucid 32 image, doesn't do very much. But it's not meant to. It's meant to be a blank slate on which you layer Apache or Unicorn or whatever floats your boat.
Maybe that's more of a chef question, but the recipes for installing that stuff, are they pretty solid? Like you get a development environment under Lucid or Ubuntu or any of them?
I've not been repeating the question. So the question is, sorry for those of you listening in at home. The question was, how useful are the boxes by themselves for someone easy to boot up? Right? Am I fairly characterizing you? They don't do much, the base ones. I mean, I have not looked in detail at the Vagrant Boxes site to see what other ones are out there, but most people that I've seen, they don't tend to put a lot of stuff on them because the intent is that you as a developer or whatever would do that and you know what you want. And of course it depends on the quality of the recipes you're using in your cookbooks. Again, I'm speaking chef here, but the intent is that those are best practices as far as how to set up. Is that answering your question, I guess? Am I?
Yeah, I mean, I guess I may have been asking a little bit more about chef than Vagrant or boxes. Like, right, so you have your standard cookbook recipes.
Yeah.
Let's say install MySQL, install Passenger. Those typically work.
Yeah, well, I mean, they work in as much that you need to tell it the directory where your app is stored and stuff. But yeah, they work. I set up one for a client that was a Unicorn setup, and it worked pretty well. So yeah, you just got to make sure your metadata is right. I kind of skipped over that because I just didn't want to have more stuff in the demo. Really, I just was trying to get your feet wet. For some reason, people find the chef part of this really hard, and I think I kind of did too. You just kind of got to dive in and do it. Because the examples are very specific to using Chef sort of alone, and Vagrant adds its own spin. So there's sort of a little translation layer that you got to get past. But anyway, hopefully I've given some good examples in my repo and you can knock yourself out. Anything else? Yes?
Would any of this help? I mean, obviously you don't want to run like a whole virtual setup in production, but is any of this helpful for production side, like being able to output maybe configs or something? I mean, you obviously want to keep those in sync, right? So
Yeah.
Your virtual boxes.
Well, I would say in the real world, the best thing to do is use something like Chef and use it to provision your Vagrant instance, and then you use those same Chef scripts exactly, or as much as possible, to provision your production servers. Then you know they're the same. You know, I mean, it's not going to be exactly the same because you wouldn't want a VM that has like as much memory as, you know, your production. It'd be awful. But yeah, the intent is to have them mirror it. I mean,
Have you done that?
I've not done it with most of the stuff I've done is like how I got involved with Vagrant was one of my clients had a really old version of Red Hat Enterprise, and they weren't investing a lot of money in their infrastructure, and they wanted me to do some changes. I'm like, I can't make these changes. This is so old. I'm not sure what it's going to do. So, oh, it's time. So thank you. You guys are awesome.